Okay, hello, welcome back. We're going to do class 4 of the algorithmic art using C sharp. And I shouldn't say C sharp because we're going to be using some other tools as well. But for now, we're using C sharp and Windows Forms. And I'll just put the camera on for a second and say hello. Hi, everybody. I thought maybe I'd get more views if I taught the class without any pants on. I am wearing shorts, so it's no big deal. If you want to see me without shorts, you got to go to my my OnlyFans page, but that's neither here nor there. Let's get right into the code. Here we go. Remember, this is the code we had. Let's just do a quick review. So everything of importance is here in this art form. Well, actually, in art form and G.C. I don't know what this art form is. I don't think we're using that. Okay, so here we are in art form. Let's just do a quick review in case, because it's been a day or two since the last class. So I'm in G. Let me go back to art form. And just real quick, we're doing all our drawing to a bitmap. We're doing it in a separate thread called the drawing thread. That way we're not holding up the interface. You can continue to work in Windows and in the app. We need to start up the thread. We need to create the bitmap, start up the thread. I should probably comment this. We also have a timer that 10 times per second it'll display what's on the screen. This is the code that's associated with the timer. All it does is call invalidate, which causes the bitmap to be displayed. This is the draw program, which I'm now calling draw 0. Oh, this was the first one where we did the lines going out. This is our current draw program, I should say our draw function, and all it does is, while true, it does an R circle to a random point with a specific radius. Now remember, R circle is a recursive circle. So it calls circle once and then it calls itself 4 times. So let's just run this real quick. And you got to click do it. And this is the recursive circle. So every circle has 4 circles inside of it, and inside of each of those there's 4 circles, and inside of those there's 4 circles, and so forth until the recursion level is met. Remember, we have to have a limit to recursion. You can't just recurse infinitely. Anyway, this is kind of a pretty little pattern. I kind of like it. But let's take a look here and see what changes we could make. First of all, I'm going to go ahead and leave this alone. And I'm going to create a new draw function. And I'll leave the old draw function there so you can play with it. And I'm just going to call this draw2. Then I'm going to go up here to the thread and associate it with draw2. So now it's going to call draw2. And coming back here to draw2, where's draw2? Okay, now notice that in recursive circle, every circle is drawn with 4 additional circles. But what if we didn't want to make it with 4 additional circles? What if we wanted to make it with n additional circles? So the first thing I'm going to do is I'm going to change the name of this from R circle to recurse. I could have kept calling it R circle, but I think I'm just going to call it recurse because this is the recursive function. Also, if you remember, well, let me just go down here and make a copy of R circle and call it recurse. Okay, good. So now, oh, I'm going to change. Did I make another copy? Let's see. R circle. Okay, so I'm going to call this recurse. You know, I'm going to call it recurse 2 because we're calling it from draw to, and so that way when we make new versions of it, we can still keep the old code around just to experiment. Now, one thing you have to be careful when you make a copy of this, you have to change. See, this is calling R circle. We don't want it to call R circle. We want to call it recurse. So Control C, Control V, Control V, whoops. So all we've done really is make copies of the same functions but given them different names. So instead of draw 1, we've got draw 2, and instead of R circle, we've got recurse 2. So that's fine. That'll work. So now if we run this program, it should work exactly the same. Uh-oh. So draw 1. Let me understand. Okay, so I go here and it says recurse 2. Okay, so do I have 2 circle functions? Draw 1, draw 2, recurse 2, calls circle, R circle. Here's circle. Call is ambiguous, so it usually means there's 2 copies of art form R circle. Okay, I'm having trouble understanding this, but that's programming, and that's why I'm sharing this with you. Draw 1 calls R circle. Call is ambiguous between the following methods or properties: art form R circle and art form R circle. Okay, so this is telling me that I've made 2 copies of R circle. So let me go get rid of one of them. I think they're both the same. So let's see, if I go further down, Yeah, here's another R circle. So I will kill one of these, and then it'll no longer be ambiguous, I guess. Delete. Okay? Yes. And now you can see I've got 0 errors and 0 warning. So I'm going to compile and run this. And okay, so it runs the same. We've renamed the functions, we've copied them and renamed them, but other than that, we haven't really changed the code. Now, I want to do a couple things. I want to change this so instead of passing it an x and y, I just pass it a point. That's not really significantly different. So I will just say, I will change this to be point f, and I'm just going to call it center. Okay, that's good. And I'll show you in a minute why I want to do this. So that means over here, instead of sending it g random f, g get random f, I will just call g dot get random point f, and it'll have 2 arguments, and the 2 arguments are going to be b width, so I can just change this b width and b height. Okay, so that's good. So now there's really no change to this. It's just instead of sending it 2 floats as being the x and y of the center points, instead I'm just sending it a point f, which is made of 2 floating point numbers. So now all I have to do is change circle here to be center dot x and center dot y. Okay. Now, of course, the recurse thing has to also change. And remember, the whole point of this was so that instead of just having 4 equally spaced points or 4 circles inside the circle, I want to make it n circles, n points around a circle. Now, to do that, I have to do a little bit of trigonometry. And I know you guys all fell asleep in trigonometry, and even what you did stay awake for, you haven't been using it, so you've kind of forgotten it. So let's take a quick look at g, because I've given you a function here. And one thing that's interesting, like when you're looking at code like this, we really don't care about what's in each function. We just want to be able to see all the functions. So let me go up here to edit, and then outline, and then say collapse to definitions. And what Visual Studio will do here is it just gives you a list of all the functions instead of looking at all the code. And here's the function that I want to show you. It's get a list of points in a circle. So what it's going to do, instead of giving me, like if I can give it a center point, and I can give it a radius, and I can get the number of points that I want, say 7 or 5 or whatever, and then it'll return a list of points that will be arranged in a circle with a given center point, with a given radius, and I can get any number of points. So let's see how we would use that in the art form thing. So I'm going to say list. And by the way, when you need more than one of something, it's often easy to make a list of it. So I'm going to make a list of pointfs and I'm going to call it points. That's good. But I'm not going to call the constructor for it. I'm going to call this function in G called get I don't know why that's not showing up in Visual Studio. Let's see. Internal static get list of points. Yeah. Let's see what happens. Get. Well, let me start over. Dot get list of points in a circle. Okay, now remember the arguments are the center point. So I will just say we already have a variable called center. So we'll take the center point. And it's also a radius, but we want the smaller radius, so I'll say new radius. And how many, instead of 4, let's have 6. Okay, so we're going to have 6 circles inside the circle to make a recursive circle. So let's get okay, so now I'm going to teach you a little bit about a loop. So for each point f in points, that's good. So it's already figured out kind of what I want. Okay, so for each point f in points, I am going to call recurse. I have to call it recurse2. So recurse2 with the color, which I'm going to say is new color because that part of the code is the same, and then the point, because each time through the loop the point will be the next point in the list, and we got a list of points from that function get list of points in a circle, and it'll be 6 points in a circle with the center point designated and with the radius designated. So I'll just say point, comma, and now I'm going to say new radius, and then comma the recursion level. Now if you remember, recursion level will work the same. When it came in, it's recurse. I guess I should spell it correctly now. Recurse level. So that's good. So now I'm going to come down here and I'm just going to make this the recurse level -1. So each time I recurse, I'll be getting closer and closer to 0, which will then invoke the base case. I got to change the variable name here as well. Okay, so let me just look at the error list, see if I see. So far this is all working. Let's go ahead and run this. I'm just going to comment this out so it'll only run once. So recurse2, you know, instead of just getting a random point, I'm going to go ahead and put it back in the center. So I'm going to say point F, and the constructor will be b width divided by 2 and b height divided by 2. I think that should work. So it's going to draw 2, is going to put this thing in the center, and it's only going to draw 1. But it's going to call recurse 2, which instead of having just 4 calls to itself, it's going to create a loop, and the loop in this case is going to call itself 6 times with these points that have been generated by this call to get list of points, and they'll be arranged in a circle. So let's just take a look. Oh, non-invocable point F. Oh, I need a new here as a constructor. And now I'm back to 0 errors and 0 warnings. Okay, let's run this. Okay, I think we didn't kill the last version. So let me get rid of the last version. This is a closed window. Okay, that wasn't exactly what I expected. You can notice I'm still not wearing pants. Okay, so let's try this. Control 5. Meanwhile, I think I'll turn the camera off. Close window. Okay, now I'm going to click do it, and I think I'm going to kill this and change the recursion level. So I forget. Oh, by the way, if you have a real long function with a lot of parameters, I like to just arrange the parameters in a list going down so that we can see what's going on. So here's the 4 parameters. The first one is get a random color. The next one is to get the center point of the B map. This one gets us a radius, which is going to be determined at random. And the recursion level is too high. So I'm just going to make this a 5 so that it won't be so boring to watch. Oh, again, I didn't kill the old one. Close window. Okay. Control 5. Click on do it. Okay. It's a little big, so we're having trouble seeing it. I think we can cut the radius down. So in draw 2, what if we just make the radius be the b height divided by 2? That should work. So we're going to make this code simpler and simpler, easier to understand, and also it's going to be easier to see what's going on. I do this every time. Close window. Okay, so let's click do it. And now we're seeing 6 circles inside of the circle. I think I'm going to change this again. So let's draw 2. Instead of a random color, let's just do red. It'll show up a little easier. So color dot red. Okay, and also instead of randomizing the color each time, I will just take this out and I will just say color equals color. So it'll be red all the time now. And I think that'll make it a little easier to see what's going on. Okay. Probably. Okay, I think that's the new version. Okay, so it's just red. It's making 6 circles inside each time. It's making the circles pretty thick. What we want to start doing is creating parameters to control all these things. And I'll go ahead and kill this so that it'll start up immediately the next time. Okay, so if we go look at the circle function, it's made it equal, the thickness of the pen is equal to 1/10 of the radius. If we made it 1/100th of the radius, that would be a thinner circle and kind of easier to see the pattern that it's creating. So let's do it. Okay, so now we can see that inside the circle there's 6 other circles that kind of overlap with each other, and inside of each of those there's 6 circles that overlap with each other, and so forth. So what if we change it to 8? Well, let's see what happens. If we change it to 8, okay. Okay, well that's kind of interesting. Maybe as we increase the number of circles, we might decrease the number of recursion. So let's take the recursion down to 3, just to look and see how the pattern's being made. Oh, I've done this again. It's always a rush to get it done before the compiler gives up on you. Okay, so maybe that's a little easier to see. If I reduce the recursion to 2, it might be even easier to see the pattern. If I reduce the recursion to 1, then it's going to be real easy to see the pattern. So inside of each circle is 8 other circles, sort of arranged symmetrically around. Okay, so close that and close this. Now, if I increase the recursion to 2, you can see that inside of every circle there's 8 other circles. This is in fact a fractal. Now, we're used to thinking of fractals as the Mandelbrot set. This is not a Mandelbrot fractal, but it is a fractal because the definition of fractal is that every part of it is self-similar to the whole picture. So this circle right here has this little flower pattern in the center. That's the same as the whole circle has the flower pattern inside of it. So just not really important to know that, but it is a fact that this thing is making fractals. Okay, So now let's set some parameters. Let's put a variable here. We're going to make it a class variable. So I'm just going to say int max recursion, or max recur. I like to abbreviate. And I'm just going to say it's 6. Okay, now also down here in circle, I'm going to say, I'm going to call this circle pen thickness, and I'm going to call it factor because it's a fraction of the radius. So now I'm going to go up here and I'm going to make a variable for this. It's going to be a float. And you know, 0.01 was kind of thin, so let's just say it's equal to 0.05. And I have to put an F here, and I have to put a semicolon. So it's going to be thicker than it was. So let's run this. Okay, so that's good. Now up here, let's go back to getting a random, we'll go back to getting a random color. So I'm just going to say g dot get random color. Okay. And that's good. And let's go ahead and make this thing loop. So I'll make it keep looping. Now what's going to happen is it's going to keep looping. Now I think there's a parameter to get random color where I can specify the alpha. Yes, it defaults to being opaque color, but I can specify a transparent color. So let me just put 32. Whoops, 32. So that's going to be fairly transparent. And the thing is, it's going to keep drawing this thing on top of each other, and it's always going to have the same radius, so that's not going to be that good. So let's say multiply this times g dot get random f, and this is going to give me 2 arguments. Now I can make it a little bigger or a little smaller. So let me make it go from 0.9, whoops, 0.9f to 1.1f. Okay, so each time the radius will be a little different, and each time the color will be a little different as well. So okay, it needs a semicolon right here. Every line in C# has to end in a semicolon. Thought I just added one, but that's okay. Oh, no, each parameter has to be separated by a comma. So I need a comma here, not a semicolon, because this is just 4 parameters in recurse. Okay, so now we're going to run this. And every time the radius is a little different, either 10% bigger or 10% smaller, somewhere in there. And each time it draws with the color has a certain level of transparency. It's 32, so it ranges from 0, which is completely transparent and you can't see it at all, to 255 where it's opaque. But now we've got a little pattern going here, and that's kind of pretty. We could make this bigger. Well, we could make it range more. We could make it go from 0.6 to 1.6. That's not completely symmetrical, but that's okay. So, and let's run that and see what happens. Again, I got to kill the old one. Okay, and do it. Okay, so this is kind of interesting. This is kind of pretty. It's kind of got a mandala type look to it. We could make it a little bigger so that it always fills the screen. Okay, so if we drew from the center point to the upper left-hand corner, if we made the radius the size, anybody remember how to do that? So we would have the math dot, and the math class is how you get math functions. So dot square root of, okay, so we want half of the height times itself and then we would like to add the same thing for the width. And what we're getting here is the diagonal from the center up to one of the corners as the radius length. So does anybody remember what this function is? This is Pythagoras. Okay, so it's the square root of the square of two sides of a right triangle is equal to the long side of the right triangle. Okay, we need to make this be width, and we need to make this be width. Now, if I'm not mistaken, the order of precedence is to do multiplication first, but don't count on order of precedence. That's a great way to put bugs in your code. So I'm just going to put parentheses here to make it clear that we want to multiply first and then do the addition and then do the square root, even though order of precedence of the operators is to do multiplication first. But don't count on order of precedence. Just always put in the code because it's easy to get that wrong. Okay. And this all looks good. Let's take a look at the errors. Oh, got a bunch of errors. Argument 3 can't convert from a double to a float. Okay. I'll put open parentheses, float, close parentheses. So that's a casting operator, so it changes a double to a float. And I've got 0 errors and 11 warnings. I think the 11 warnings were the last time I compiled this. I had the program running, so that produced warnings. So I think if I just so Control 5 and I can click do it, so now I'm getting a kind of pretty kaleidoscope type thing going on. Using different colors every time. Now, sometimes you get too much color. So what I'm going to do up here is I'm going to say that color, and the convention is to capitalize the function type and to use lowercase for the variable. So I'm just going to say that color equals get random color 32, so equals Control V, semicolon. So now the color is this. Now here, instead of getting a random color, I'm going to say change color. So the colors will all be somewhat related. Change the color, and the color that I'm going to change it from is color, and the change factor I'm going to use, I'm going to put it in a fairly big change factor. So I'm going to call it 80. And again, this change color also has a parameter for the alpha, which defaults to 127, but I'm going to make it 32. So that should make this more interesting. It's not quite as colorful, but sometimes too much color. I got to go back here and close this. So there's two annoying things about this code right now. Is that one, I have to keep pressing the do it button. And two, when I close this window, I forget to close the do it window. So let's see. Maybe I'm making this too transparent or not enough change. Let me go back, and this time I'll close this, and I'll make this 64. That might be better. And I might bump up the change factor to 100. Okay, let's see what happens. Do it. You know what happens is the original color, in this case it seems to be like a yellow, doesn't change. So instead of constantly getting a change color from color, I'm going to say right up here, I'm just going to say color equals get change from color. So instead of continuously changing the same color, now each time it's going to change the color, and it's going to get a changed color from the last color. So now it should go through more transitions of different colors. Maybe too much. Now I'm going to reduce the amount that it changes each time to maybe 30, and I'm going to also make it more transparent. I'm going to take the transparency down to 32. Let's try this again. Okay, maybe more interesting. Okay, so now the next thing we want to do is save the picture. Okay, so instead of saying while true, I'm just going to make it go around 20 times. So I'm going to say for int I equals 0, semicolon, I less than 20, semicolon, I plus plus. Okay, so that's good. That means the for loop's going to end. Now, at the end of the for loop, I'm going to call g dot, and I've got a function here somewhere in G that will let me save the image to, okay, just save art, and the argument is to a bitmap. And it works out the whole thing. It's going to put it in this directory, which is going to be this at the same level as the outer directory, and it's going to save it as a JPEG, so it won't take up too much space. So let's go back here to Artform and g.saveArt, and we're going to send it bitmap. Now, there's a little problem here. And the problem is that you can't have two different threads accessing the bitmap. So what we want to do is we want to, first of all, we want to take our invalidate timer and just tell it to stop. Okay, that's good. Now, we want it to invalidate one last time before it, so that the entire image is drawn. Otherwise, there might be a timing issue. Now, there also might be a timing issue if we just immediately save the art. So I'm going to say thread dot sleep, and this will just put this thread to sleep for a little while. And so I'll just say thread dot sleep, and I'll make it wait 1 second, so that's 1,000 milliseconds of sleeping. And now let's see what's going to happen. Now, I've already played around with this, so what I'm going to do is I'm going to go into that directory and I'm going to erase everything that's there. In fact, I'm going to erase the directory. So this WFUT artworks is where it's going to place the art, and I'm just going to delete the whole directory. Okay, and now I'm going to run this again. And by the way, there is some code in here that if the directory doesn't exist, it'll create it. If the directory already exists, it'll just create the bitmap, well, actually the JPEG file in that directory. So let's go ahead and run this. Control F5 and click do it. And maybe I should have made a little beep noise or something, but in any case, I think it's done. I'm going to close this and close this, and then let's go look in the directory. And so here's, did it create the directory? WF T artworks. Oh, may have left it down at the bottom, maybe? Yes, left it down at the bottom of the list. So let's look in this directory, WF Tut Artworks. And there's one image in there, and that is this image. We can look at it in paint.net, and that's it right there. Don't remember it being black. Maybe the original image was the original image was probably transparent, and so it left it black. Let's go fix that. So in the draw to object, we will okay, remember that drawing to the bitmap is done with lowercase g. Do I have cap lock on? No. Okay, so g bitmap dot clear, and we'll just have it clear to color. And of course this line has to be underneath the line where we determine the color. So we'll just stick the line underneath there. Okay, now I think we need to make this bigger. So let's make this 50, and I think we should make this smaller so that it's more transparent, so you see more of the colors underneath. So let's see what happens here. And do it. Okay, still a little faint. We could make the original color I've got a function here called darken. So g dot darken color. So it gives you sort of the same hue and stuff, just darker. So it's got a lot of the same qualities. And I will make this I'll just make this 255, so it'll be completely opaque. So the first time it draws, it'll be completely opaque. So Control X, and then I'll have it only change the color afterwards. So the first time it'll draw, it'll be completely opaque, and then afterwards, maybe 16 is too low. Let me try 32 again. So let's see what happens here. Okay. Color, and then how much I want to darken it. So I'll just say comma 0.7F. So it'll be a much darker version of the same hue. So let's try this again now. No argument corresponds to the alpha. Okay, so I have to specify the alpha here. So I'm just going to say comma 255. So I'll make the background opaque. think it's done. One way of checking to see if it's done is to go over into this directory, and yes, it's done. By the way, this is paint.net. It's sort of like Microsoft Paint, except that it doesn't suck. And I'm going to say don't save. Okay, now to make this a little more interesting, first of all, I'm going to close this. Well, to make the program a little easier to use, I'm going to go back to the original forms thing, and I'm going to have it, I'm going to add a timer here so I don't have to keep pressing the do it button. I'm just going to say timer. Oh, I gotta do all that stuff here. I don't know if you remember about timers. I have to say system dot windows dot forms dot timer, and I'm going to call it the start timer. And I could either put the new here, so let's see, equals new system window start timer. Okay, so that'll create a timer. And then down here, I'll just say start timer dot interval equals, I'll just have it start up a half second after the other thing does, after the program starts, half a second later it'll start the artwork. And then I'm just going to say start timer. Here the syntax is a little weird, so dot tick plus equals, and then you just press tab and it'll create the whole thing for you. So it's created a function down here called start timer. Okay, now when the button clicks, it does this. Now I'm going to highlight all this. Then I'm going to right click on it. Whoops, not somehow unhighlighted. Okay, I'm going to click on this, and I'm going to call extract method, and I'm going to call this start the art. Start the art. Okay. Now the reason I took it out of put this down here in the button click is so that I can make the timer do the same thing. So I'm going to make it start the art. Okay, so now I'm not going to have to click on do it. It's going to automatically start the art after half a second, so that just make this a little easier. I do want to leave the button because the button will allow me to start additional copies of the art. So let's press, make sure we've closed it. So Control 5, and it wants a semicolon here. I forgot to press the tab. Okay, so now it's happy. Let's do a Control 5. And I didn't see it start. Oh, huh. Okay, let me close this. We set up the timer, we made the interval, we set where it was supposed to go, but we have to say start timer. Oh no, yeah, that's what we're calling it, start timer. start timer dot start. You have to actually start the timer. So you think of it as like a stopwatch. You have to click the button once to make it go, and that'll start it. Okay. Oh, wait. It'll keep doing this every half second. That would be crazy. It would just keep creating more and more artworks. What we have to do down here, after we start the art, we have to turn the timer off. So I have to say start timer dot stop. I mean, we could leave this out and then every half second it would start another art, but they're all full screen, so we wouldn't even notice. And after a while, we'd consume all the resources, memory, CPU time, and everything else. So, not a good idea. Okay, so now after half a second, the artwork starts. I'm just going to kill this and kill this, and now go back to draw 2, which is where we're currently working. That's over here. Draw 2, and I think 20 is not enough. Let's make it go around 200 times. Should maybe make a more interesting image. And if we're going to do it that many times, I think we'll reduce the opacity of the image of the colors down to 16. Let's see what happens. Okay, so it's kind of doing a little bit of a dynamic show. There is a way, like if inside of the timer we could make it save the bitmap to a file, and then it would all go into a subdirectory, and then there are utilities that will take like a whole bunch of JPEGs and turn them into a movie. So maybe we'll do that another time. But for now, we've got this. Now the other thing you can do is just run OBS and copy the screen. Of course, then that might not be the optimal way to do it, but it is an option. So now if we go look at the folder, we can see that we've created all these different artworks. Now, it's a little bit fuzzy here. We've got to, let's take a look at circle. Let's put the rectangle statement up here. It doesn't really matter whether it's in a different order from the radius. I'm sorry, with the pen creation. So I'm just going to put it first. Then I'm going to put a little space here, and then I'm going to go Control C, Control V, and draw another circle. But this time I'm going to call it black pen, and I'm going to make it equal to the circle thickness factor. I'm going to make it a third as thick times 0.3333, and of course these are all floating point numbers, so I got to put an arrow. And then I'll just say draw that with the black pen. This will add a little definition to it, and I'll show you in a minute. We can drop the max recursion down to 2 so we can see better how this is going to work. And I think I will bump this back up to a 1/10, because what it's going to do is it's going to draw a colored circle, but it's going to draw a black circle inside the color circle. So let's just go back to circle. Oh, I don't want to make this the same color. I want to make this black. So I'm going to say color dot black. Okay, so we're just experimenting here, but I think this will add a little more definition to the image. Okay. Sort of. What happens is the black, the black is, okay, I got another idea. Instead of saying it black, I'll just say, remember I had that darken function? So I'm just going to say g dot darken. I'll make a dark version of the same color, and I will make the color factor 0.5F, and I will make the alpha on this one 32. Okay, so instead of doing it in black, it's going to do it in a darker version of the same color, but and also with some transparency. Let's see how that looks. Okay, again, you have to close this, do it. It's kind of more interesting. Okay, so we're doing this always with 6 circles. What if we made it with a random number of circles? So I could just say, and there's a little trick to using random. The way I was using random before is not really the right way to do it. But here we've specified 8 as being the number of points that we get in the list. But what we could do is say g dot, no, let me back that up. I just say random dot shared dot next, and we're going to make this be any value from, say, 4 up to 8. Now remember, the way the random works, it'll give you a random number up to the second value but not equal to it. So this will give me a value, well, I tell you what, let's take this down to 3, and let's take this up to 12. So it'll be a different number of circles going around each time. So let's see what happens now. So I need a close paren, because this random function is actually an argument to the get list of points in a circle. So I need another parenthesis there. I'm not sure. It all kind of fuzzes out. Let me close this off and close this off, and I'm going to go up and make a parameter out of this. So I'm going to say int number of points equals, and then I'm going to go grab that code from down here. So where is that? Oh, it's down in recurse. So here I'm going to take this out and just say num points, and then I'll go back up here to num points. Where am I? Here we go. And I'll put this back here. So this might be interesting. So it's gonna do it with the same number of points each time, but every time you run the program, it'll be a random number between 3 and 11. So let's see what happens. I think it's more interesting when it uses the same value every time. Okay, it's going to go 200 times. Okay, maybe that's too much. You know, 200 is overkill because it just covers up the whatever was there before in the bitmap. I'm going to close that and close this, and I'm just going to have it go 20 times. But I think I'm going to make it change the color a little more. So I'll just say 100 here. Remember, that's the color change factor. So the higher it is, the more the color will change each time. So okay, well, that's kind of pretty. And I think that's saved. It's kind of like a mandala type thing. Okay, so I'm going to close that. Now, part of what makes it less interesting is that it's only drawing the whole pattern with one color. But let's just say that instead of, I've got another function here that returns a list of colors. So let me go list of color, close bracket, and I'm going to call it the color list. That's fine. But instead of calling a constructor for it, I'm going to say equals g dot get list of random colors. That's what I want. And I can give it a color as an argument. So that's the color. And also a change factor. So I'll just say 60. I don't know. And also an alpha. So I'm going to say 16. Okay, so now I have a color list. Okay, and instead of passing color, I'm going to pass the color list. Because what I want is that each level of recursion will use the same color, but each level will be a different color. So I don't know if that made any sense, but down here I'm going to have to change this to list of color and I'll call this the color list. Good. And now, oh, I need to get past it a number, how many colors I want, right? So let me just see what's going on here. Let's see. I should be able to draw 2. Okay, let me just do an open parenthesis here and get what the different parameters is. Oh, so I need another for count, and I will have this be comma max recur, and little trick, you have to make this +1 because it's going to go from 0, 1, and 2, and so that's good. So I got that. And so this will give me the list of colors. And then down here, instead of using color, I will use color list. And the way you get individual items out of a list is you say square bracket, and I'm going to do recurse level. I hope I'm not making this too complicated, but I think if you go through it, and also I'm going to post the code so you can look at the code, recurse level, and then I can't pass color here. I don't need new color because I've already got all the colors I need. I can get rid of both of these lines, and I'll just pass color list. So what's going to happen is it's always going to use the same. Every level of recursion will use the same color from the list. Let's see if that. Let me open the error list and okay. So max recur is assigned a value, but it's never used. Okay. So first of all, I want to make this bigger. So I'll make this 5. That should make the thing more interesting. And down here, instead of passing it 2, I'll pass it max recur. And when I create the color list, I will pass it max recur +1. Did I misspell it somewhere? Int max recur is assigned a value but is never used. I think I have used it. Max recur, did I spell it different? Okay, so it's a slight problem I have. It's claiming I've never used it. Let me compile this again. Okay, so it's happy now. Okay, I'm gonna, it may eventually create some interesting art with a high level of max recur, but while I'm debugging it and working on it, I think I'm going to bring it down to 3. Now the other thing is, I don't see the darkened lines. Let me go look at circle again. New pen color. Let me go refresh quickly how darken works. Oh, 0.5 will cut it in half. Let me make it much darker. I'm just going to say 0.7. And instead of 32, I'm going to put 64, so the darkened color will be less transparent. And circle pen thickness, 1/3. So that should actually put it right in the center of the circle. Okay. Doesn't seem to be coming up with a very interesting list of colors. Let me kill that. Go back over here. And let me go where it makes the list of colors. That's up here in list of colors. Okay, let me make this 120 just so they're very different. Let's see, Control 5. Okay, I like it. I think the center of the line could be even darker. So let me go back. This is where, you know, you got to use the left brain and the right brain. So you got to use the rational part of your brain to do the coding, and the artistic side of your brain to do the artwork. So here you are an artist, you know. I'm going to say 0.9. I'm going to want these really dark. So let's see what happens here. Oh, I got this backwards. 0.9 doesn't make it dark, makes it almost the same color. So what I really want to do is say 0.2. Okay, let's see what happens. Control 5. Okay. Okay, so there's some reds and purples there in the list, but I don't think the list is changed enough. Oh, there's not a lot of recursion. You know what? I'm going to wrap this up. But look what we've done. We've made it so that it saves the bitmap at the end. I'm gonna let you guys experiment and see who can come up with the most interesting images. So here's recursion level 6. That's gonna tend to be a little slow. I'm gonna let this run. And if the image comes out nice, I'll use it as the thumbnail on the YouTube video. So let's see. It's kind of pretty. And see, instead of just using a random color as it builds each level, it's already determined those colors in advance. So I think this is making an interesting pattern. It's a little slow, so it's taking a bit of time. I've been looking at new computers. It says now's a tough time to buy computers because the the graphics cards, the really good ones are too expensive, and the cheaper ones are a little weak. So I'm holding off. I'm making do with my old computer. It's still running good, but it'd be nice if I got a computer that ran faster. This computer's about 7 years old. It's an i7 with 6 cores. This is back before Intel CPUs were screwing up. Right now, I would never get a computer with an Intel CPU, and I'm sorry about. I apologize to Intel, but that's just how I feel. I'd want to get something with an AMD processor. AMD has a new processor. It's the Halo Sticks or something, and it's got some interesting properties. And it's interesting to me because it's got a lot of computational power, but it's very efficient. And because I live in a motorhome, I'm kind of limited to the power. You know, we do all right. You know, we have a microwave and a toaster and a coffee maker and a washer and a dryer and all that stuff. But if I start running them all at once, I'll exceed the 50 amps that I have in my coach. So this is pretty. I think this is a very pretty pattern. I like the blues and greens, and I know as soon as I say it, I'll jinx the whole thing, and it'll start using other colors. But it appears to be kind of sticking to those colors. It's got symmetry. You know, and that's okay. It kind of makes it look like, you know, like a stained glass window in a church, or some sort of mandala in a Buddhist artwork. In fact, it might be interesting to paste a little image of a Buddha right in the center of this. Let me think about that. And I think we're going to call it a wrap. And I want you all to have a great day. And as the homework assignment, I want you to take this code, which you can see in the first pinned comment at the bottom of the YouTube video, and modify it and make some artwork of your own. So I'm just going to let this run, and when it ends, I will shut down the video. I should play some music, but then I'll get a copyright violation and get my YouTube video taken down. So maybe I won't do that. So this time it did it with 6. So that's what we've been doing before, but I think it's random. If I ran this again, and what did I'm doing this 20 times around? That's a lot. So I'm not going to cover any more material. The code's going to be down below. You're free to sit and watch this finish, or if it's too much like watching paint dry, um, you can let it go. It should create a very interesting image. Um, and I don't remember what we specified the dimensions of the bitmap, but the bitmap could be very large. In fact, I think the a good size for the bitmap is actually 16,200 by 10,800. And the reason for that is because there's a company called Spoonflower where if you send them the JPEG, they'll print the whole thing onto cloth. And the best cloth that I've found for printing images is their satin. And I haven't printed anything in a year or two, so I'm not sure what they're charging. They used to charge somewhere between $20 and $35 for each print. Now, if you take this to Kinko's, they'll probably charge you $100 for a print the same size on paper. And what I do with the satin is I get a wooden frame and I stretch the cloth on the wooden frame, and then I staple it. And so it makes a kind of pretty artwork. It seems to be using the same colors each time it draws. I don't know why that is. By the way, if you do this with a really large bitmap, like 16,000 by 10,000, although I should be clear, what you want to use is 16,200 and 10,800. Then you can do it at 300 dots per inch, and it fits exactly on the satin cloth that Spoonflower has. And if you do it at that resolution, this will be even slower, because every time it draws one of these circles, it's got a lot more calculations, because it's got to go, there's a lot more pixels at that resolution. And this right now may seem to be slow, but I've had works that I've sent to Spoonflower that had to run overnight to render the image. But then after it's printed, Spoonflower does an excellent job. They only messed up one print out of maybe 50 or 60 prints that I've had them make. And the one print that they messed up, I called them up and they redid it. So Spoonflower is an interesting company. It's a little startup, and they've taken inkjet printers and modified them to print on cloth instead of paper. And they have an interesting YouTube video where they show what type of equipment they have and the processes that they use. But they do an excellent job. I haven't been there in a while. I sure hope they're still in business, because they were the absolute best place to get artwork printed. Just watching this this picture is like a meditation. If you stare at the very center of the image and just take some deep breaths and sort of let your mind sort of go into neutral, you can have a nice meditation. And on that note, I think I'm done here. It looks like the picture's done. I like it. It's subtle, and so I'm going to wish you all a great day. Go play around with this code, see how you can change it. If you come up with a nice image, send it to me. My email is bokaaratom@gmail.com. So send me a picture. If you have anything in the subject line, mention algorithmic art class so that I can find you amidst all the junk that I get in email. Anyway, guys, have a great day, and I will see you all later.